Okay. Morning, everyone. How are you doing? Hey, not enough coffee? How are you doing? Good. Good. My name is Victor Mushkatin. I'm a program manager at Microsoft on Ops Manager team. And today we'll be talking about DevOps. It turned out that DevOps is something that I've been working personally for quite some time. How many of you have heard about AviCode or used AviCode Intercept Studio? Okay, I see a couple hands. I used to be a founder and CTO of AviCode, a company that was primarily focused on application performance management software. And in 2010, Microsoft acquired those assets and completely integrated into Ops Manager 2012. So it turned out that I've been working on this problem of providing actionable feedback from production to development for like 6-7 years now. And what I'd like to do during this session is essentially talk about the problem, the way we understand it, and propose a solution how you can address certain pain point utilizing Microsoft Stack. Specifically, I'll talk about deployment, how to make deployment to be consistent. I'll talk about how to really understand what's going on with application in production. And third, I will focus on how to make support loop to be as seamless as possible to significantly reduce MTTR, mean time to resolution. So I will not show you a DevOps product, a product for DevOps person, because I don't believe that there is such thing like a DevOps product. As well, I don't think that there is a person like a DevOps person. Instead, I will show you a set of products that together would facilitate DevOps lifecycle. I'll show you how to use VMM to provide a consistent up deployment story. I will show you how to use Orchestrator to tie those deployments together. I'll show you how to use Operations Manager to provide deep monitoring insight into applications running in production. And then I'll show you how to use Visual Studio ALM tooling to simplify the problem support and for problem troubleshooting. Okay? Just a disclaimer, for developers, I will not show a lot of coding, okay? And for operations, I will not go into any of those products deep inside. For example, I will not show you how to set up, virtual networks in VMM. Instead, I will focus on a story, end-to-end story, to convey key points, how to make that story real using Microsoft Stack. So DevOps, what is it? I believe you've seen this kind of picture before in various presentations. How many of you are devs? Would consider? Whoa. Okay. How many of you are IT pro? Okay, some. Great. So I'm sure that like 80% are devs and 20% ops here. I'm sure that many of you have seen this picture and in various talks where we're talking about continuous, essentially, life cycle with developers focusing on the left side with their sprints, delivering code into production, and in IT Pro are managing applications in production, monitoring it, and both developers have their backlog. IT Pro have their own backlogs. And as you see, there are a lot of friction points in this kind of life cycle. Specifically, I remember when I started doing development and I moved to US, I was working for a cell phone debit cell phone company. And we have a number of offices in Hartford, St. Louis, Wethersfield, 7x24 operations. And typically, all our deployments were over the weekend, where like 800, we're all on the conf bridge saying, hey, everybody's ready? Ready. We're turning our IVR system into maintenance mode. Done, done. We're starting a backup. Let's reconvene at 1000. 10 a.m., we all on the call. Backup's done, done. Did you verify it? No. continue. So it was a very painful process, and we were spending weekends. And I remember one time deployment didn't go well, and we couldn't roll back for various reasons. So we could go only forward, and we didn't really know how to go forward. And we spent 36 hours straight fixing the problem. Okay? So I don't want that to happen ever again. And that was a pretty big pain point. The second thing that I've seen with our customers and experienced myself is it's pretty embarrassing when customers know that your application isn't working and you have no clue. So ability to detect that your application is down is pretty important. And I'm talking about and I've been on both sides. I've been a dev that have no clue what's going on in production and customers complaining. And I've been on production, on a customer side, keep complaining that particular service isn't working and proving to the other party, to the third party, that it's not working. So the biggest problem is that right now, in many cases, IT focuses on just the infra. And I may have a perfectly fine IaaS. I may have perfectly working SQL Server, but IT reconfigured a firewall in between, and right now, let's say traffic 1433 port is closed. So my application is failing. And unless I monitor the application, from the infra standpoint, everything's fine. I have IaaS is working, I have firewall is working, and I have SQL working fine. But my app is down. So how I can detect problems when they occur? But it goes further. Let's say I found out that the problem exists. My customer called, or I was able to detect myself. Then what? Where would I go to collect the meaningful data? Where should I start? Okay? And from development perspective, it's also pretty painful. As a developer, I want to have access to my production environment. Ideally, I'd like to attach my, core debugger, AD+, in a hang mode to collect the mini dump and see what's the thread execution. It ain't going to happen. I will not have access to my prod environment. So these are the problems that we all face supporting live operations. And how to address those problems is exactly what I will try to describe during this talk. So DevOps, there are a lot of talks in the industry. What is DevOps? There are no-ops discussions, DevOps, ops discussion. To me, if you have dev and ops, you have a DevOps process. DevOps process is nothing but communication between when devs are talking to ops are talking to dev. And they take shared responsibility for running service. That's it. It's plain simple. So we all have DevOps processes. Granted, not everything is smooth, frictionless. And that's essentially the whole promise of DevOps, to make that communication easy. So if we're talking why right now DevOps is getting to be more and more popular, what are the major driving factor for DevOps adoption? There are a few. First of all, times when you're doing your deployments annually or semi-annually or quarterly are long time gone. We see customers doing monthly, weekly, daily deployments. Flickr is doing 10 times a day. There are properties at Microsoft that are on average doing deployments once an hour. With that kind of speed, you have to rethink a lot of processes. You have to rethink how you monitor your software. It's a different game. Moreover, right now, a lot of companies are adopting this idea that your competition is a click away. You're trying to deliver your B2B, B2C SaaS offering, and you're trying to lower the barrier of adoption, but guess what? Your competition is doing the same thing. And if your customer just trying your software and not fully vested, it is very easy for them to kind of move to your competitor. So ability to monitor your end user experience, real end user experience, is becoming very important. So you quickly understand that something isn't working right. Ability to not just release the whole software in one shot, and ability to kind of try a new feature set on a small sample of customers, this A/B testing type of thing, is becoming very important. Okay? But it goes deeper than just health monitoring. It's not enough to just detect that, hey, I have a problem and I'm fixing it. If you are familiar with the Lean Startup idea and book by Eric Rice, there was an example where they were working on a multi-IM software. They spent about 6 months on it, and about a couple hours they put a page on a web with a download button. Nobody clicked on that download button. So the point was that instead of wasting 6 months on development of something, they could spend 2 hours putting a page and get a feedback from customers that whatever they've done doesn't make any sense. So it is very important to have targeted dev investments. It's very important to understand how your end users actually using your site, okay? And whether you need to improve on a feature or you just want to cut the feature and reduce the complexity of your software. So that's what DevOps is all about. Getting the actionable, meaningful feedback from production servers. Making sure that your deployments are automated. Now, if it's all that great, why don't we all have it? There are a number of issues that organizations usually face when they try to adopt DevOps process. First of all, and I believe the biggest issue is the cultural change. Because right now you have dev managers, dev organization, you have ops organizations, siloed, and they purchase software completely independently. And as a result, they don't think that the output of dev process should be natively consumed by ops, and vice versa. That output of ops monitoring system should be natively consumed by dev. And as a result, there is very limited interaction between dev and ops. Now, those artifacts, since those artifacts are not natively shared between different tooling, there's no common process. There's no common process and there's no common automation for this process. And that really prevents friction-free DevOps interaction. So today we'll talk about how to make that process seamless. And specifically, we'll be talking about 3 distinctive processes. How to do deployments, monitoring, and support. Now, when I'm talking about deployments, I'm not saying that, hey, I have an MSI or, let's say, web deploy package, and I'm deploying it on an endpoint. Deployment is a more complicated process. It's an orchestration of multiple steps, okay? I need to make a backup before I do the deploy, right? I'm doing a deploy sequencing the deployment steps, okay? After I've done my deployment, I want to validate that whatever I deployed actually works. And if it's not working, I want to roll back to well-known good state and probably notify my engineering team that, hey, something's wrong with the bits. And that's what we need to automate to support agility. From the monitoring perspective, it is important to understand what type of problem are we monitoring and how to monitor particular type of those problems. Let's say how to monitor availability, how to monitor that my site is up, how to monitor performance. And also it is important to not only detect the problem, but once you detect the problem, collect meaningful information so you can provide that information into support loop, into problem management cycle. So on the dev side, I know how to address it. So we will be covering those 3 processes during this talk. And again, I will be using lots of tools. There are lots of demos. So if there is a terminology that you're not familiar with, especially since most of you are devs, and I'll be showing lots of tools that are ops specific, please raise your hand and ask the question. I won't be able to go deep into a particular product. However, I'm really interested to make sure that you guys understand how all these products fit together. Okay? So what I'm going to do is I'm going to start talking about a tailspin toy company, and okay, we're back in demo. Tailspin toy company, and I will be switching hats. I'll be acting as a dev, I'll be acting as an ops, and then I'll be acting as a dev again and ops again. So I'll try to articulate when I'm changing my roles. And right now, I'm a dev. And Tailspin Toy Company is we have a web presence. We sell model of airplanes. We believe that everyone should fly, and if you can't afford the real plane, you can at least buy a toy. And we recently moving our operations globally. We're opening up our UK operations. And I'm making some changes to support this new initiative. And as a dev, what I have, I created a new code. And as a matter of fact, I'm going to introduce a bug. I will remove tax rate for UK. And what I'm going to do is I'm going to check in these changes. But before I do the check-in, what I'm interested in, I want to configure my continuous build. So what I want is, I want every time when I'm doing a check-in, I want to start my build, okay? And as also, I want to make sure that as I'm starting my build, I want to run series of tests. Okay? Basically, I want to run all my unit tests to make sure that everything is clean. Okay? And at the end, what I want to do is, I want to make sure that I will output a package. And right now, this project consists of two packages. I have a DAC my SQL DAC and I have a web deploy. And what I want to do, as a result, I want to essentially create those deployment artifacts and, quite frankly, go home. Okay? Because I know that as a result of my build, I ran series of tests, unit tests, and I would claim that whatever I've done is done. It's ready for production. I also want to make sure that once I move the code in production, and at the time of moving that code, I would provide ops with a way to actually verify that whatever I deployed actually works. So what I'm going to do is I'm going to record a web test for a number of my operations. In this particular case, I recorded a web test for checkout, because I believe that ability to collect money is one of the key features of my web presence. So I pre-recorded this web test, and if as you see that at the last step, I'm doing a validation that I will have a credit word on a page. Okay? Just to make sure that I process successfully, I walk successfully through the credit card validation process. So what I'm going to do is I'm going to do the check-in. So I see my pending changes. I'm doing a check-in. Okay. And I believe that if I go to builds, I'll see my build. Oops. I'll see my build. And it will take time to run this build. But for now, what I'm going to show you is that the application actually works. So I'm going to check out. And this is the scenario that actually I pre-recorded. I go to checkout. I have a United Kingdom. I click review orders. And I will get a screen in a second where I have my, okay, this is my credit card information. And what I'm doing is I'm validating, with my web test, I'm looking for this content, this word. So I believe that if I have this word, it means that the page is up and running. Okay? That's my validation. Now, if I go back to my dev machine, I'm running I'm still running build. So it will take some time. And while it's building, what I can do is I can essentially show you what I have as an ops person. As an ops person, I'm running Virtual Machine Manager. How many of you have heard about VMM? Okay, good. So I will not talk about lots of features that VMM provides. There's one feature that is very important for this particular talk, is a library. And as an ops person, I know that I have to support this new service, Tailspin Toys web presence. Okay? I'm planning to put that service in my private cloud, so that therefore I'm using VMM. Now, I know as an ops, I have to consume some of the artifacts that developers give me. And those artifacts would be web deploy and DACpack. So what I have here, I have a library of those artifacts. Let's say this is my Tailspin web deploy package, right? I have my SQL scripts. I have my DACpacks. So I have essentially a repository of everything that devs giving me in my tool. I also have a list of VHDs, right? Those are my virtual images. In this particular case, I have an image where I have OS and SQL on one image, sysprepped image. And I'm going to use that image to basically stitch together application and the virtual infra. Okay? And to do so, I'm going to use a new feature called service template. And let me show you what the service template does. So service template is essentially ability for me stitch together a couple things. My image, and in this particular case, for this demo, I use single tier application, essentially everything, my website and my SQL are running on the same image with my application artifact. So if I go to my single tier, go to properties, what I'd be able to see is, I'd be able to see that on this service template, I have web applications, my web deploy, and my DACpack, okay, and my SQL. So what I have effectively, as an ops, I prepared a service template that then I can use to target installation into particular environments, okay? Whether it's a pre-production, production, okay? And because I have this service template, I guarantee consistency of those deployments. Now, let me show you that most likely from the dev perspective, see, I'm done. I'm done with my build. I have essentially I have my drop location, and this is the result of my work, right? This is a web test that I was mentioning. This is my DACpack, and this is my Tailspin web deploy. So I just showed you that I have to consume this output that developers prepared for me in the ops tooling. And for that, I'm using service template. So now I configured my service template. And this is if you will, I wouldn't call it a one-time deal, but the topology of the application changes less frequently than the application code itself. So what I want to optimize for, I want to optimize for daily releases, weekly releases. Okay? So what I need to do is I want to make sure that I somehow can automate my deployment of this service template. So every time when developers sending me notifications that, hey, code is ready for production, I want to automatically, with a click of a button, take that code and do the deployment. And that's exactly what I'm going to do. So what you'll see on the screen, again, I'm an ops person. I prepared a deployment script, deployment orchestration. What you see is System Center Orchestrator product that allow me codify my whatever process I have. And in this particular case, I created a runbook to automate deployment. Let me set a breakpoint here. And while it's running, I will talk what it's actually doing. First of all, in VMM, just to show you, we are running a version of a service template, version 46. And that's very important that service templates are versioned, which means that every time when I have a new build, I can create a new version of a service template. I can apply that service template to a particular instance. And if that instance isn't working, I can roll back. Okay? So I have versioning for my service templates. Now, it looks like right now I'm running version 46. What I would expect that at some point this version 46 would change to a new version because, again, I'm taking a new build and I'm pushing that build into prod. Okay? But also, I want to make sure that as I'm doing that deployment, I somehow verify that whatever I released on production actually works. And here's how I'm doing that. So first of all, as part of my deployment automation, I'm backing up SQL. That's my first step. Second, I'm going to my TFS for a particular project. I'm checking whether where should I go to grab the new deployment bits. I'm taking those deployment bits and I'm putting them into my VMM library. And in deploy service step, I'm actually creating the new service template, and I'm applying that service template to an instance. And as a matter of fact, since we passed that step, if I go back to VMM, you see, right now, deployment is 53. So I created a new service template, now 53, and I deployed that service template to my site. Now, back here, what I'm doing after I deploy service template, I'm verifying that whatever I deploy actually works. I'm using web test to validate the deployment. Now, it is very important that I'm using that web test at that point. The reason is that as a developer, I'm usually going after, I can validate against my particular, backend with, 5 records. Once I'm moving into production, I'm testing it against real production data. And in my case, I might not even, in many cases, I might not even catch some of the issues that are data dependent, that are working fine in development, and might not work completely in production. So that's why it is very important to validate the deployment. And as you see, actually, in this particular case, what we did is we validated the test, and we didn't go to return success. What you see is we now going to the red arrow. We're now doing activity snapshot failure, because I know that there's a bug in application. So we essentially detected that there is a failed deployment. And right now what I need is, I need to capture that failure state, put it aside, notify my service engineers that, hey, there was a problem with most recent deployment, and then roll it back. Okay? As a matter of fact, right now, we are in a, we kind of got to the point of a rollback. And as you see, right now, we're running template version 53. So now let me show you that it's actually a broken code. So if I go back to the service and do the same process, like I go to checkout and UK, right? And you remember that as a developer, I commented out the UK tax rate. So if I click review order, boom, I got error. See? So I have a broken build in prod. And what I want is, I want that build out, and I want to collect as much data about this problem and provide that to service engineering so they be able to understand how to fix it. So I'm going back, and you know what, I'll finish it. So what will happen now, I will roll back completely that deployment to well-known good state. And on the ops side, I already collected all the alerts, all the information about this failure, and I automatically send that data into development. So now if I go to dev, let's say next morning, I as a dev come to work, and if I go to my work items, and I search for operational issues, I will have this issue. So essentially, there is some kind of failure happened in my production. So I also would have essentially a list, a link to my to the transaction file. Remember, when we run this step to do the web test, we actually collected the TRX file. So now what I can do is I can essentially open that file, and it happens like at 1:43. It's a Seattle Pacific time zone, about 3 minutes ago. So what I can do is I can open it up and see that, hey, there was an error on the page. So now, as a dev, I have information about how it's failing. Okay. I also have, as a dev, I have a link to my snapshot. Okay. So technically, what I could do, I could go back. I could rehydrate my my environment and start debugging on the side. And that's very important, because now I have complete information about what's going on in production with that particular deployment. Now, if I go back to OM, most likely it's done. Yeah. So you see that it's done. And if I verify VMM, yeah, we're running version 46. So we went back to well-known state. And if I go back to the service, okay, you remember this checkout process? I go to checkout, and I click review order. Fingers crossed. Good. So we're back to normal. This is like a Apollo 13 case, successful failure. We were able to deploy the service, validate that whatever build is not working, and completely roll back. Back to well-known good state. And we were able to do that by using VMM, and specifically a feature called service templates that allow me to create enable consistent, reliable, and repeatable deployment of application artifacts into a particular environment, and orchestrator that allowed me to stitch together a pretty complicated process. Okay? So this is how I was able to automate my deployment. Now, so this is essentially what I've done. I went through this deployment orchestration. First step, we did a backup. Then we deployed applications using service templates. Then we validated using web tests. After we determined that it wasn't working, we're able to roll back the whole environment. We're able to notify developers and created a work item with complete information about what was going on at the time of the deployment. Now, that's good. After you've done deployment, now you have to monitor things. Okay? And here, there are a lot of challenges. Typically, the conversations between IT pro and devs goes like this. So how to monitor this .NET applications? And developers are not sure, what do you mean monitoring? It's working fine in staging. But from ops standpoint, they see that they have no clue when something isn't working, and they rely on customers to report about those issues. So developers are trying to get more information about the failures, but ops guys, in many cases, have no clue how it's failing. And then developers are getting sometimes very defensive, and conversations turn to be very philosophical. So this is the problem. This is the problem. So what we need to do is we need to, this is due to unreliable incident detection and very limited knowledge that goes back and forth between devs and ops. And as a result of that, there is a lot of finger pointing, brainstorming, and wasted time. So what type of problem we need to be monitoring for? What type of issues can we detect? I would focus on 3 major points. First, availability. You need to know that your site is up and running. That's priority 0. Everything else is immaterial. If you have an outage, you jump. That's pretty clear. Second is performance. Reliability. Which means that if your end user experiencing random failures, you need to know about it. And this is especially so in multi-tenant environment. You may look at problems across all the tenants, and on average, across all of them, everything's fine. But there could be one tenant that is completely down. And for that tenant, for the users of that tenant, your site is down. So in this case, this reliability problem could be escalated, elevated to availability problem. And the last one is performance. And performance is something that everybody intuitively understands that my site should perform fast. But how to measure that? How to collect the root cause? How to know which components is running slow? Now, there are different types of problems, of all these problems. Some problems are expected. Some problems are unexpected. For example, the typical scenario is printer out of paper. This is well-known failure mode. So your app should not crash when you're trying to print and the printer is out of paper. This is a known expected problem for which workaround can be coded, can be provided. And you as developers, what you can do, you can create, if my connectivity to clearinghouse is down, then write this event log into event log, this event into event log, and then ops guys would be able to react on that particular problem and go fix it. Because they know that, hey, this issue happens when my T1 connectivity to clearinghouse is down. And I need to do A, B, and C. Those are expected problems. But there are a set of unexpected problems. Right? Something that you did not expect as a dev. Due to code bugs, failures, data inconsistencies. In many cases, for example, if you're running out of memory and if your application is under stress and GC is not fast enough to remove, to clear up the memory, you may experience some type of memory leak, right? And you may start failing right and left. As a dev, you don't know what needs to be collected. Or when your application is running slow, what do you want to collect? I've seen a lot of devs are using tracing for the monitoring purposes. That's not, at least in the customers I've seen, that didn't work. And the reason why it didn't work, because I've seen pretty big customers with lots of volume on the website, and what they had, they use Log4net to essentially instrument every function. Guess what? They overwrite their production logs once a minute. So by the time you trying to get to that log, the data about the problem is long time gone. Because there is a difference between tracing for the purpose of troubleshooting and the monitoring. So how to make your monitoring be efficient? How to collect data only when you really need to collect that data, when you have a problem. And this is exactly what I'm going to demonstrate you in the next demo. Okay, good. So, are we in business? Okay. So what I'm going to show you is Operations Manager. And there are a lot of investments that we've made in Ops Manager, specifically around application monitoring. So now what you can do is you can monitor your application, what we call 360, from every angle. Basically, what you can do is you can look at your applications from the availability standpoint, reliability, and performance standpoint. Okay? And for this, I'm going to use a slightly different app. As a matter of fact, I will open up this summary dashboard, which looks pretty cool. And I'm going to use Dinner Now. Okay, this is another sample app. And what I will do is I will do a search here. Okay. Go to the main page. I'll do a search, and you will see that in Ops Manager, I will collect the data about the performance of this application. So I'm searching some restaurants in area, Redmond area, 45 minutes away, and it takes time. Obviously, there is some performance issues, right? Now, what I can do as an ops person, I'd be able to see all these problems show up, all these performance problems. So now, as an ops, I can detect those issues. Now, what kind of issues I can detect? In this case, I show you some exceptions, but the point, the interesting point is my, let's say this is, I believe, my search. Yeah, this is Dinner Now search. Oops. So this is how my application actually work from the client perspective. So I was able to look at my clients, how my client actually perform, and go all the way down to my servers. So I can see this is my client, talking to my client web page, talking to my front-end servers, those front-end servers talking to my back-end web services, and I can go into the back-end web service and essentially see why this particular web service is taking that long. And I see that this SQL statement took over 3 seconds to execute. So we were able to go from the client all the way down to the server. Okay? Sure, go ahead. No, No. The question is whether this will going to work only if everything on one machine. No. It's a agent-based technology. As long as you instrument each tier with an agent, we will be able to collect those events independently and stitch them together. Yes, go ahead.
What's the name of the management pack?
Yeah, I'll go there next. So the question is, what's the name of the management pack? So now, how can you do this? So what we did is we introduced a number of management packs that allows you to implement this. So first, I'll start with availability monitoring. And we introduced, I don't know how many of you have seen Jason Zander's keynote yesterday, where he introduced global service monitoring. Essentially, I don't have the full global service monitoring here because this machine is completely isolated from the internet. What I have is essentially, this is, let's say, Tailspin Watcher. This is a, if you will, global service monitoring where watcher nodes are inside our data center. But the same concept applies for global service monitoring from POPs, point of presence around the globe. Okay? And the idea is that we can execute synthetic transactions from around the globe to validate the availability of a particular feature of your application. Okay? And that's very important to detect availability problem. Availability with resources. And, but you don't have to set up a lot of points of presence. You don't have to set up a lot of those availability validation, availability tests, because in most cases, if you can open up a page, it means that your IIS is up. If you can, let's say, log in, it means that your RBAC, your authentication authorization layer, connectivity to backend DB is up. If you can, I don't know, process credit card transactions, bad credit card transactions, and get incorrect and get correct error code, it means that your connectivity to clearinghouse is up. Most likely, these tests are targeted for very critical use cases in your applications to validate resource availability. For everything else, we suggest you use a different feature called .NET Application Monitoring. Oops, .NET, not Java. And in this case, I prepared for my Tailspin toys a .NET monitoring. And what we do when Ops Manager gets installed, it discovers all .NET components that you have. And now, for example, if I click Add and search, I see a list of all the app components that we discovered around the globe, around your enterprise. Now, you may have one VHD with, I don't know, 5 websites, 3 web services, and we will be able to discover them independently. So in this case, we're not monitoring a VHD, a VM. We're monitoring individual app components. And then for each app component, what we can do, you can configure server-side monitoring and the client-side monitoring. So client-side monitoring is that event that I showed you at the beginning. Essentially, what it gives you ability to see how end users actually seeing your applications, experiencing your site. And what we do is, before we spit out HTML stream, we basically intercept that, and we automatically inject small JavaScript into your page. That JavaScript attaches to the DOM model. It collects essentially DOM loading time. It can validate. It can monitor how much time you spend on AJAX execution and so forth. That's what client-side monitoring gives you. Server-side monitoring gives you the picture from the server internal, server side itself, which means that it's an agent-based technology. And unlike client-side, where client don't have to install anything, you just use a browser and it will be automatically. Those agents will be injected automatically. in outputting HTML. With a server-side technology, it's an agent-based technology. You have to have SCOM agent on the box. And we do bytecode instrumentation at assembly load time. We intercept the assembly loader. We do the bytecode instrumentation, putting our code there. And on the fly, we can collect exceptions, critical exceptions, and performance degradation. So as an ops, I can basically specify that, hey, my SLA is 1,000. So every time when the page is slow and the request is slower than 1,000 milliseconds a second, I will get data about this call, okay? From the dev standpoint, you don't have to do anything special. You don't have to instrument your code. And this solution focuses specifically on unexpected problems, something that you did not code specifically for. So every time, for example, when you have a data inconsistency and your application fails because it doesn't correctly handle DB nulls, we would be able to capture the exact root cause with complete call stack with all the parameters, so you'd be able to repro that issue. And as a result of this configuration, and I showed you a couple wizards, right? Web application availability monitoring and .NET application performance monitoring. What you could do, you could create distributed application inside Ops Manager, and as an ops person, you would be able to see your KPIs on this dashboard. And that's essentially all you have to do. Run through a couple wizards, and you get all this information, and you'd be able to collect meaningful data that developers would be able to relate to and start fixing the problem. Okay, question?
What is the performance price of this injection in every request? And you inject the JavaScript?
Very good question. So the question is, what is the performance hit of injection and all that magic? There's no miracle. If agent works, it spends CPU cycle. But that's where the fundamental difference between tracing and monitoring, this type of monitoring. Even though it might sound very controversial, our job is not to collect data. Let me explain what it means. It means that, let's say you have a button that doesn't work. 1,000 people click on that button. We will collect only first 3 events with the root cause. For everything else, we ignore it. We'll basically keep a counter that the same problem happened another 997 times. So our job is to shut down our monitoring when we feel that we already collected the data before. So we have lots of throttling mechanism to make sure that we're not wasting precious CPU cycle in production environment. Now, I'm pretty sure that you will go into deeper details on another session that we'll have later today. But just the way we're measuring performance impact in terms of RPS, requests per second degradation. So let's say you can process 100 requests per second with no monitoring. With our monitoring, we guarantee that you process no less than 95. Under 5%. Okay? Yeah, there was another question. Oh, good. Developers, yeah. So, but clearly, there's no magic. Now, with this 5%, in reality, our customers, most of our customers won't notice any performance overhead. And the reason is, if you have a SQL call that, let's say, over 100 milliseconds, and you have a thread waiting for the response, our performance overhead are so negligent compared to this 100 millisecond waiting time that in most applications you won't even notice it. You will notice it when you're talking about, I don't know, millions of transactions, and every transaction's, I don't know, 20, 30 milliseconds transactions. There, you would start noticing those performance overheads. But for typical line of business applications, the cross-process call to your web service or to SQL, cross-network call to SQL server, already so slow that our instrumentation overhead will be most likely not noticeable. So this is how you could do the monitoring. Now,
Sorry. For the SQL server, it's the same because we're talking about the application server. But if you have the separate SQL server, you collect data there. So, and as I get, you will get the SQL data.
that is correct.
Yeah. So it's kind of crazy there.
Let me show you. The thing is, SQL, what we call is observed tier. In other words, we're not running the agent there, and instead what we do, this is our WCF, right? Instead, we're just monitoring that, hey, there was a call to SQL, and this is how much time it took.
So you don't run traces.
We don't run traces. We basically, from the .NET, like execute Scalar or whatever, right? We're bytecode instrument that, and we're measuring how much time did it take, okay? It's pretty simple. No, you don't have to have agent on the SQL server. Because we're instrumenting the middle tier that talks to SQL server. Okay, go ahead.
Which platforms are our agents available?
It's a .NET platform monitoring for now.
I see a web server.
We...
Injected into Windows applications or desktop applications.
Yes, yeah. We're right now we have a generic .NET agent that supports essentially any anything, any W3, WP. In SP1, we will support Windows services as well. Okay, so and then you basically attach the monitoring to a particular process, and you'll get all of this. But again, hold off on those deep questions because there is a separate session where you can dive into actually how it works and how to really set it up. Excuse me? Yeah, I have a slide. It's that session at 2 o'clock, and Pei will be delivering that session. So let me continue. So how to get information from production into development. So far what I showed you, how to get your bits into production. I showed you how to configure monitoring in production so you collect data. And remember, I showed you a bunch of alerts that we were able to collect in the Ops Manager with pretty cool information inside. And the next question is how to get that data back into the hands of developers. So we have yet another template, another wizard that you have to go through in order to configure this communication. So this wizard called TFS, work item synchronization. So it addresses couple issues. First of all, you have right now your TFS server and you have SCOM server. TFS server has its own terminology, like projects, portfolio, so forth. Ops Manager has its own taxonomy with MPs, with alerts, with managed, monitored components, discovered components. So you need to first marry those two systems on a security level, which means that Ops Manager and SCOM servers could talk to each other. And second, you need to map discovered components that you discovered in SCOM to the projects, to the objects, if you will, on the TFS side. And for that, you would use TFS sync, which would allow you to first configure your security settings, as well as map monitored components. And in this case, what I have is I mapped Tailspin discovered components, not only discovered and configured. right? And right now I'm monitoring a bunch of components. But I'm mapping my tailspin to my TechEd 2012 project, okay? So if you would have multiple projects, you'd be able to say that these components, discovered components, belong to this project. These components belong to that project, okay? And as a result of that, every time, if I go back to, let's say, tailspin overall component health, and every time when I, let's say, right-click on something, and as an ops, and assign to engineering, oops, that problem will get escalated to appropriate project inside TFS. Okay? So let me go, actually I can escalate this. Let me go and show you before the problems that we've escalated when we've done the deployment, right? This was the problem. And I showed you that we collected the TRX. Remember, when we run this web tests, actually it was a failure that Ops Manager detected. And as part of my automation script, what I did, I automatically escalated that failure to development. So this is essentially my work item. And this TRX answers the question, how does it fail? But it doesn't answer the question, why? And what I'm going to show you is a feature that is coming to System Center, but it will be coming as part of our SP1. Remember, I showed you those events with some data, with performance data. Those events are pretty much operational view. And developers might not have access to those systems, to SCOM console, to the op diagnostic consoles. So what we've done is we took those events, those alerts, rather, and we converted them into IntelliTrace log file. And we attached that IntelliTrace log file to the work item. So now I can open it up and run a IntelliTrace debugger session. How many of you are familiar with IntelliTrace? Okay, good. So the point is that we were able to convert information collected in ops into language that understandable by dev. And that's a very important thing that we've done. Now, what if this is not enough? Because, again, monitoring is not the same as tracing. Monitoring is essentially an assert. I have a problem, I'm collecting last frame. But in many cases, developers look at that exception and they say, well, you know what, I have no clue how end user ended up in that such situation, right? And you need to get more data. You need to see how end user actually progressed through the, I don't know, wizard to get to the failure. For that, you need to full IntelliTrace. And in SP1 timeframe, we released a feature, we're going to release a feature, that would allow you to actually get that. Now, as a dev, let's say I'm back in my operational issue 19. I go to history and say, basically, if I can type, hey, dude, need full IntelliTrace. Okay? I'm saving in history that, hey, I need more data. So in reality, this would go back to Ops console. And if I go to my, this is my server, that problem would appear eventually here. But what I can do is, as an Ops person, I have this alert. So now as an Ops, I have a shared context between dev and Ops. In Ops, I have alert. In dev, I have work item. And we can communicate to each other. What I can do, I know that I received a request to start IntelliTrace. What I can do is start IntelliTrace. And here I would see the list of all servers that my application is running. And I can start IntelliTrace log. And I just realized that I'm running out of time, so I will show you the end result of this IntelliTrace. So I'll be able to essentially go through the wizard. Again, check out. And at some point, take a snapshot that then will be sent to a dev. And I bounced because we had to attach IntelliTrace, I bounced W3WP process. Okay. So that's why it's taking some time to restart. Okay, I'm back into business. So, and the point is that now what I can do is I can start IntelliTrace collection. Okay, and that would essentially, collect IntelliTrace snapshot. That would take a snapshot from that box, and we would send that snapshot to the TFS item. And if I go back to development, I prepared operational issues with that snapshot. Okay, if I go back to my operational issues, if I can find those operational issues. This number 16. So what I did, what you would see is, in attachment, you would see this type of, another snapshot. If this one, 31 meg, right? And if I go into that snapshot, I would have a full-blown call stack. Sorry, trace. Okay? So what we essentially enabling, we introducing a, first of all, we merge the notion, we kind of map the notion of monitored components to a project. That's number one. Second, we created a sync between an alert and a work item. Third, we're able to essentially extend monitoring with troubleshooting functionality. We converted our monitoring artifacts into IntelliTrace, and we enabled full IntelliTrace agent monitoring in production. And we tie it all together. Okay? This is end-to-end. It can't get any better than that. Okay, question?
Well, the full IntelliTrace was so throughput goes down drastically.
It will go down. We're working on special plans. I don't know if you're familiar with IntelliTrace. Special plans to make that less impactful. But granted, monitoring is not tracing and troubleshooting. When you are in a tracing mode, you will collect data by definition because you want to trace everything. Monitoring, we will start dropping data. Okay? When we feel that the impact of a monitoring is too high, we have so many heuristics to shut down monitoring, data collection. Sorry, not monitoring, data collection. When we determine that the impact is high. Okay, so this is essentially end-to-end story. Now, let me summarize what you've seen during this session. DevOps is coming. We are DevOps. Okay, it's a transformational change. In order to ride the wave, we got to change. And Microsoft has Stack end-to-end to facilitate DevOps interaction. I showed you how you can use System Center VMM to guarantee consistency of app deployment. Consistency, reliability, repeatability of app deployments. I've demonstrated you how to use Ops Manager and new features like GSM, Global Service Monitoring, to implement availability, how we were able to collect client-side performance, how you can go dive deep into the code with no changes that developers have to do. I showed you how we were able to do problem management using Visual Studio Stack, TFS and VSU, IntelliTrace. Okay? And I showed you how you could tie this whole process end-to-end with an orchestrator. In my particular case, I showed you how to do the automated deployment, but you could do, let's say, scale up, scale down with the orchestrator as a result of monitoring. For example, you detect that perf is going high, you need to add another instance. You could orchestrate that and change that on the fly inside Fabric, inside VMM. So just to put it in one picture, what we've done, we first enabled continuous integration inside Visual Studio. Then we took deployment artifacts from dev and imported them into VMM library. Third, we deployed service template into targeted environment. Fourth, we're able to detect abnormal application behavior and collect meaningful information. And fifth step, we were able to escalate that problem into service engineering for problem management. That's essentially what we've done, end to end. Now, call to action. Get on board with it. Install System Center. Talk to your ops if you dev. Talk to your ops to embrace System Center Stack. Now, if you ops, talk to your dev, embrace Visual Studio Stack. There is a related content. So there is a session on ALM, Dev 317. There is a session specifically on IntelliTrace, Dev 390. I would recommend you to go to a session on VMM to basically get familiar with VMM. It's MGT 314. Deep questions about monitoring, and I showed you some miracles happening here, but you can go get answers to most of your in-depth questions on the session MGT 302, Application Monitoring with SCOM. And to learn how to codify your processes, go to Management 325. Okay? Now, we have lots of resources online available, right? Various blogs. Please provide a feedback to us. And submit evaluation. It's very important to get feedback from you. We are in a DevOps cycles as well. So I want to know whether this session was effective, what type of things you would expect from a DevOps process, because it's something that is very interesting for us, for Microsoft, and it's something that we all cannot, we can run, but we can't hide. DevOps is coming. Thank you.